I am looking at the light curve on my monitor right now, and I can tell you, with absolute certainty, that what we are seeing shouldn't be happening. If you look at the standard cometary models, the ones we have used for decades to predict the behavior of dirty snowballs sublimating as they swing past the sun, this object, 3I Atlas, should be fading. It should be quieting down as it recedes from perihelion. Instead, the data stream coming in from the Chilean observatories and the trailing data from the Stereo spacecraft suggests something entirely different. It is brightening. Again. And not just a subtle fluctuation, but a geometric spike that defies the inverse square law of illumination so aggressively that I initially assumed the sensor calibration on the CCD array was faulted. It wasn't. To understand why this is keeping me and half the planetary defense community awake for the last 72 hours, I need to take you back to the beginning, to July 1st, 2025. I remember the alert hitting the Minor Planet Center database. It was flagged by the Atlas Survey, the Asteroid Terrestrial Impact Last Alert System, specifically the unit in Rio Hurtado. At first glance, it looked like noise, a magnitude 19 faint smudge moving against the background stars of Virgo. We see these all the time. Usually, they turn out to be main belt asteroids or typical long-period comets falling in from the Oort cloud. But the orbital solution didn't fit. The eccentricity, the parameter that tells us how elongated an orbit is, was wrong. A circle is 0. A parabola, an object with just enough energy to escape the sun, is 1. This object had an eccentricity of 6.1. I need you to grasp the magnitude of that number. 1I, Oumuamua, the first interstellar visitor we saw in 2017, had an eccentricity of 1.2. 2I Borisov, the second one, was around 3.3. An eccentricity of 6.1 is not just fast, it is unbound on a scale that implies an origin with immense ejection velocity. This object wasn't just drifting through the galaxy, it was shot out of its home system like a bullet. When I first ran the backward propagation simulations, tracing its path back through the years, it didn't align with any nearby star systems within the last few light years. It has been traveling in the void, deep in the interstellar medium, for likely hundreds of millions of years. And now, it is here, inside the orbit of Mars, acting in ways that make me question our fundamental understanding of cometary physics. The primary anomaly that caught my eye wasn't the speed, though 67 kilometers per second relative to the sun is blistering. It was the composition. When we pointed the heavy glass at it, the Very Large Telescope and later the James Webb Space Telescope, we expected water ice. That is the standard volatile. Comets are water-rich. But the spectra came back clean of strong water signatures. Instead, we saw carbon dioxide, massive amounts of it. And beneath that, a metallic signature that shouldn't be there in those quantities, nickel and iron, but specifically atomic nickel vapor in the coma. We saw this with 2I Borisov, but the ratio here is extreme. It suggests that 3I Atlas isn't a fluffy snowball, it's a dense, potentially metallic-rich body that is shedding its skin in a way that mimics a comet but operates on different thermal mechanics. But the real crisis, the reason I am recording this log, began in late October. As 3I Atlas approached perihelion, its closest point to the sun, roughly 1.3 AU out, we expected it to fragment. The tidal forces and the thermal shock of going from the near absolute zero of interstellar space to the searing heat of the inner solar system usually rip these fragile visitors apart. Comet C 2019 Y4, Atlas, disintegrated under similar stress. We watched the light curve, waiting for the telltale knee in the graph that indicates the nucleus has crumbled into a cloud of dust. If it crumbled, the surface area would skyrocket, and the brightness would flare briefly before dissipating into nothing. That didn't happen. The nucleus held. It survived perihelion intact. But then, as it emerged from behind the sun, shielded from our view by the solar glare for weeks, the Stereo A spacecraft, which sits in a different orbit and could see around the side of the sun, sent back images that made no sense. The object had brightened, yes, but not in the way a disintegrating comet does. It was a sustained, exponential increase in luminosity. It was glowing bluer than the sun. Color is information. In astronomy, blue usually means one of two things: high-temperature emission or very fine scattering dust, like cigarette smoke. For a comet to appear bluer than the star it is orbiting is incredibly rare. It implies that the particles being ejected are microscopic, perhaps submicron in size, and they are being pumped out at a velocity that exceeds the thermal expansion speeds of simple gas sublimation. Something was driving this material off the surface with force. I spent the last week analyzing the heartbeat, That's what we're calling it in the lab, though we haven't used that word in the papers yet. The light curve isn't a smooth line, it has a periodicity. Every 16.1 hours the brightness pulses. It dips and rises. This is consistent with the rotation of the nucleus. Imagine a potato-shaped rock tumbling in space. As the broad side faces the sun, it reflects more light. As the narrow end faces us, it dims. That's standard. But the amplitude of this pulse is increasing. The peaks are getting higher, while the troughs remain stable. This tells me that there is a specific active region on the surface, a jet or a vent, that is turning into the sunlight, blasting out material and then rotating into shadow. But here is where the verified data gets unsettling. The anti-tail. Usually a comet has two tails. The dust tail, which curves along the orbit, and the ion tail, which points straight away from the sun, carried by the solar wind. 3I Atlas has a third feature, a narrow, collimated spike of light pointing towards the sun. We call this an anti-tail, and usually it's an optical illusion caused by the geometry of the Earth crossing the comet's orbital plane. You see the dust trail edge on, and it looks like a spike, but we checked the geometry. The Earth was not in the orbital plane crossing window during the stereo observations. The anti-tail is real. It is a physical structure of material being ejected sunward. For a natural object to eject material toward the sun, against the flow of radiation pressure and the solar wind, the ejection velocity must be high. It has to overcome the push of the sun's light. We calculated the necessary velocity. The particles need to be leaving the surface at nearly 1 kilometer per second. Normal cometary outgassing is maybe a few hundred meters per second. This implies a mechanism much more energetic than simple ice turning to gas. Some of my colleagues are proposing cryovolcanism, pressurized pockets of liquid nitrogen or carbon monoxide trapped deep inside a metallic shell, bursting out like a geyser. It fits the data mostly. It explains the velocity, it explains the pulse. But it doesn't explain the timing of this new brightening event I am looking at right now. 3I Atlas is currently moving away from the sun. It is receding. The heat input is dropping. By all laws of thermodynamics, the activity should be shutting down. The cryovolcanic vents should be sealing up as the crust freezes over. Yet, the integrated magnitude has jumped 0.5 magnitudes in the last 24 hours. It is acting as if it is receiving more energy or releasing stored energy that was somehow delayed. I pulled the polarimetry data from the observatory in La Palma this morning. Polarization tells us about the surface texture. Light bouncing off a rough, dusty surface is polarized differently than light bouncing off a smooth, metallic, or icy surface. 3I Atlas shows strong negative polarization. This is characteristic of primitive, dark, carbonaceous material, similar to the darkest asteroids in our system, the C-type asteroids. But if the surface is dark, it absorbs heat well. This supports the idea of a thermal lag. Maybe the heat from perihelion took 2 months to soak through the crust and reach a buried reservoir of volatiles. And what we are seeing now is the delayed reaction. A massive subterranean cavity finally reaching critical pressure and blowing its top. That is the comfortable theory. That is the one we will put in the abstract of the paper for the Astrophysical Journal. It is safe. It relies on known physics. But I have to look at the outliers in the data, the things we usually filter out as noise. There is a slight non-gravitational acceleration affecting the trajectory. We saw this with Oumuamua too. It's a push that isn't caused by the gravity of the sun or the planets. For a comet, this is normal. The jets of gas act like thrusters. If a jet is pointing east, the comet gets pushed west. We call this the rocket effect. But the astrometry for 3I Atlas is incredibly precise because ESA's Gaia mission and the Mars orbiters, TGO and MAVEN, helped us triangulate its position when it passed near Mars in October. We have a lock on its position to within kilometers. The non-gravitational acceleration is there, but it is purely radial. It is pushing the object directly away from the sun. If the rotation is tumbling, as the light curve suggests, the jets should be spraying in all directions, averaging out to a net zero or a chaotic push. To have a sustained, unidirectional push away from the sun while the object is tumbling requires the jet to be effectively turning on only when it faces the sun and turning off instantly when it turns away. That requires a very thin surface crust with zero thermal inertia, meaning it heats up instantly and cools down instantly. That contradicts the delayed heat soak theory I just mentioned to explain the late brightening. You cannot have both. You cannot have a thick crust that stores heat for months to explain the late explosion, and simultaneously a thin crust that reacts instantly to explain the non-gravitational push. The physics are in conflict. This is the tension of modern science. We are staring at a contradiction. Either our model of the object's structure is wrong, or our understanding of the mechanism driving the activity is wrong. Let's talk about the specific wavelength data coming from the MUSE instrument on the VLT. We are detecting emission lines for cyanide, CN. This is typical. But the ratio of nitrogen to carbon is skewed. In our solar system, comets formed in the Kuiper belt have a specific isotopic fingerprint. Comets formed in the Oort cloud have another. 3I Atlas has a fingerprint that matches nothing in our library. It suggests a formation environment rich in rare earth metals and heavy elements, perhaps near a supernova remnant or a neutron star merger in its original host galaxy. This might explain the high nickel abundance. If this object is a fragment of a planetary core from a system destroyed by a stellar cataclysm, it might be far denser than we assume. If it is a chunk of a planetary core, then the cometary activity is even harder to explain. Iron and nickel don't sublime at these temperatures. You need thousands of degrees to vaporize iron. We are at distances where the surface temperature is maybe minus 50 degrees Celsius. So where is the gas coming from? It must be a matrix, a sponge of metal filled with ices. But how does such an object form? We don't have a formation model for ferrous sponges. The brightening event today is localized. I've been looking at the pixel-by-pixel breakdown of the coma images. The brightness isn't uniform, it's asymmetrical. The coma is expanding faster on the leading edge than the trailing edge. This is highly unusual. Usually, the tail trails behind. Here, the puff of new material is moving in the direction of travel. This suggests an ejection velocity that is adding to the orbital velocity. It's like throwing a ball forward from a moving car. I am currently running a simulation to see if this could be a collision. Space is empty, but it's not that empty. 3I Atlas is crossing the ecliptic plane, the heavy traffic zone of our solar system where all the dust from asteroids and comets hangs out. Could it have hit a micrometeoroid? A rock the size of a marble hitting 3I Atlas at 70 kilometers per second would deliver the kinetic energy of a tactical bomb. That would explain the flash, the sudden brightening, and the release of dust. It would also explain why it happened now, random and unpredicted. It's a tempting solution. Interstellar object hits local debris. It wraps it up nicely. But the spectroscopy doesn't support a single impulsive event. If it were a crash, we'd see a flash and then a cooling expanding cloud. What we are seeing is a rising curve. The energy output is increasing hour by hour. It's not a crash, it's an ignition. The vent, or whatever it is opening wider. I must address the alien hypothesis, simply because I know it is the first thing the public asks. Avi Loeb and his team have already put out preprints suggesting the non-gravitational acceleration and the shape could be consistent with a light sail or an artificial probe. As a scientist, I deal in probabilities, not possibilities. Is it possible? Non-zero. Is it probable? The probability is vanishingly low compared to natural explanations we haven't fully understood yet. Nature is more imaginative than we are. Every time we think we've found aliens, we've actually found a new type of pulsar, or a new quasar, or a new atmospheric chemistry. The universe delights in tricking us with phenomena that masquerade as intelligence but ultimately turn out to be some exotic physics we had not previously catalogued. Still, I understand why the idea persists. It appeals to our sense of cosmic drama, to the human desire to not just be observing the universe but to be observed by it. But the burden of proof for such a claim is astronomical, and we are nowhere near that threshold. However, I will concede this. The behavior of 3I Atlas is pushing the boundaries of the natural box we are trying to force it into. The precise 16-hour heartbeat, the collimated sunward jet, the lack of water, the durability near the sun, and now this post-perihelion reactivation, it is a laundry list of oddities. If I were designing a probe to sample a star system, I would want it to be durable, metal-rich. I would want it to use resources for propulsion, volatiles, and I would want it to wake up and transmit data or maneuver when it was closest to the star. 3I Atlas mimics that behavior perfectly, but mimicry is not proof. The heartbeat is easily explained by rotation. The maneuver is explained by outgassing. The durability is explained by high metal content. We can explain every single anomaly individually with natural physics. The discomfort comes from having to use different, somewhat contradictory natural explanations for each anomaly. It feels as though we are assembling a Frankenstein model of nature, stitching together explanations that work in isolation but don't quite harmonize when placed side by side. That tension is what keeps scientists up at night. Not the idea that aliens might exist, but the idea that nature is trying to tell us something new and we don't yet understand the language. The scientific mind is trained to be suspicious of coincidences, but it is also trained to avoid leaping to conclusions simply because an explanation feels clean or narratively satisfying. Aesthetic elegance is not the same as truth. Right now, however, I cannot deny that 3i Atlas has an aesthetic to its anomalies. They line up too neatly, like symptoms that point toward a single cause, even when the underlying processes should be disparate. It should not have a heartbeat-like photometric pattern, and also a sunward jet, and also a lack of water, and also high thermal tolerance, and also a late-stage reactivation. A single explanation should not be able to account for all of those simultaneously, unless the object is somehow more complex than typical cometary nuclei. But complexity can still be natural. We have seen comets with stratified layers, comets with oddly shaped nuclei, comets that tumble chaotically, comets that disintegrate without warning, and comets that outgas from highly localized vents that behave unpredictably. The solar system is full of misfits. The interstellar population may simply be more misfit than anything we're used to. Right now, the telescope arrays in the Canary Islands are coming online. Night has fallen there. I have requested high-cadence photometry. We are going to take a picture every 30 seconds for the next 6 hours. We want to catch the heartbeat in high resolution. If the pulse shape has changed, if the vent has migrated, or the rotation period has shifted, that will tell us about the internal structure. A shift in rotation period would mean the mass ejection is significant enough to act as a torque, spinning the object up or slowing it down. That would give us the mass loss rate, and from there, we can estimate the total mass. If we can nail down the total mass, we can finally determine whether it behaves more like a solid bullet or a fragile assemblage of porous ice. Right now, the guesswork is borderline embarrassing. The current mass estimates are wild guesses. We have constraints from the Hubble images which place the nucleus between 400 meters and 5 kilometers wide. That's a huge margin of error. If it's 400 meters and made of iron, it's a heavy bullet. If it's 5 kilometers and made of porous ice, it's a cloud. The lack of orbital perturbation from Jupiter's gravity suggests it's heavy enough to not be easily bullied by the planets, but the non-gravitational acceleration suggests it's light enough to be pushed by gas. Again, a contradiction. This contradiction is what complicates the analysis more than anything else. A heavy object shouldn't respond dramatically to outgassing. A light object shouldn't resist Jupiter's gravitational influence so easily. We are stuck between two incompatible interpretations. It's like watching a person lift a car with one hand and then struggle to carry a grocery bag with the other. You can't fit both observations into one coherent model of their strength. And yet that is exactly what 3i Atlas is demanding we do. Either our assumptions are wrong or we are missing some key physical variable. That missing variable might be the density, it might be the shape, it might be the thermal conductivity, it might be a multi-layered internal structure like a chocolate bar with layers of nougat and caramel. Except in this analogy, the nougat is porous organics and the caramel is iron-nickel alloy crust. Or it could simply be rotating in such a way that the jets are firing off at angles that trick our measurements. Comets are not spheres. They are messy, lumpy, unpredictable bodies that can behave like malfunctioning sprinkler heads. In some sense, 3i Atlas reminds me of the first observations of Oumuamua. People forget that before the alien hypothesis gained traction, Oumuamua itself was a nightmare for dynamicists and modelers. The shape, the acceleration, the reflectivity, the thermal properties, none of it fit comfortably inside existing boxes. We learned from that episode that the universe does not feel compelled to adhere to our categories. Categories are human inventions. Reality is under no obligation to respect them. Even so, there is something distinct about 3i Atlas that sets it apart from Oumuamua. Oumuamua stayed silent after perihelion. It did not reactivate. It did not show a vent. It did not create a jet. 3i Atlas, by contrast, is noisy, persistent, stubborn. It refuses to fade into the background. It behaves more like a living organism with cycles of activity rather than a passive rock drifting through interstellar space. Scientists hate entertaining biological analogies for astronomical objects, but the metaphor is tempting. Activity cycles, pulses, reactivations, these are the behaviors we see in stars, in geysers, in volcanoes, and yes, in artificial machines. The key is that all these systems have internal structures and processes that drive periodic outputs. 3i Atlas must have some kind of internal reservoir or thermal mechanism that is regulating its venting. Maybe the metal-rich exterior acts like a pressure cooker, trapping volatiles until cracks form. Maybe the rotation causes stresses that open and close vents in a cyclical fashion. Maybe the 16-hour interval is simply the time it takes for a deeper pocket of trapped gases to reach the surface after sufficient heating. Each hypothesis has its merits, but none of them explains every observation simultaneously. That is why high-cadence data is essential. Photometry is our stethoscope. If we can map the pulse precisely enough, we might see substructures in the light curve, tiny dips or spikes that indicate multiple vents, or asymmetries that point to surface features, or changes in amplitude that correspond to fresh outbursts. Every pixel of data is a clue. There is another layer to all of this that the public doesn't always appreciate. When an interstellar object enters our system, we get one shot at studying it. It's a visitor, not a resident. Once it leaves, it is gone forever. There is an urgency to these observations that is difficult to convey. We cannot wait for the next orbital cycle because there is no next cycle. There is no second pass. If we miss something today, that gap in knowledge becomes permanent. That is why astronomers fight for telescope time like lawyers fighting over evidence. The stakes are higher than usual. In a decade, 3i Atlas will be nothing more than a memory and a set of incomplete datasets we will regret not having improved. Every time a frame is taken, every time a spike shows up on a graph, we have to treat it like a once-in-a-lifetime opportunity. The more I study the object, the more I find myself wrestling with the limitations of our instrumentation. We are peering at something potentially hundreds of millions of miles away, smaller than a mountain, rotating unpredictably, expelling gas in microscopic quantities, and moving at tens of kilometers per second. The fact that we can measure anything at all is a testament to modern astronomy. But measuring is not the same thing as understanding. Just because numbers exist does not mean they arrange themselves into a coherent story. That is the challenge, turning fragmented signals into a narrative of what this object is and what it means. The temptation, of course, is to fill in gaps with imagination. That is where the alien hypothesis sneaks in, not because it is supported by evidence, but because it provides a single, unified explanation. Humans crave unity in explanations. We prefer one strong theory over 10 weak ones. But the universe is often a place of 10 overlapping causes, rather than one elegant solution. As we continue gathering data tonight, I'm acutely aware of the emotional component driving public fascination. People want connection. They want to feel less alone in the cosmos. They want wonder. They want mystery. Objects like 3i Atlas feed that hunger. Even if this object turns out to be nothing more than a strangely shaped, metal-rich, intermittently active comet, it already serves a purpose. It forces us to re-examine assumptions. It forces us to widen our models. It forces us to consider that interstellar space may be full of diversity our solar system never prepared us for. And if, by some microscopic chance, it were artificial, the consequences would be profound. Not because the object is a messenger, but because it would prove that technological intelligence arose at least once outside our solar system. But again, that leap requires evidence, and right now, all we have are puzzles. What I can say with confidence is that the strangeness of 3i Atlas is real. It is not a media fabrication. It is not a hallucination of overexcited astronomers. The data is unusual. The behavior is unusual. The combination of anomalies is unusual. But unusual does not equal unnatural. It just means we have more work to do. Tonight's observations are only one piece of the puzzle. Radar data, if we can get it, will provide another piece. Spectroscopy might offer clues about surface composition. Thermal modeling might reveal how deep the vents go. Orbital modeling might tighten the constraints on mass. None of these alone will solve the mystery, but together they might form a mosaic coherent enough to eliminate the extremes, both the hyper-natural and the hyper-artificial. The truth is likely somewhere in the middle, grounded in physics we partly understand and partly need to expand. For now, all we can do is observe, interpret, and remain patient. Science often advances not in leaps, but in slow, deliberate steps, each one small, each one incremental, each one frustratingly insufficient on its own. But the accumulation of these steps leads to understanding. And if understanding 3i Atlas requires wrestling with contradictions, embracing ambiguity, and facing the limits of our models, so be it. That is the nature of discovery. The object may leave our system soon, but the questions it raises will stay with us, shaping our theories, our expectations, and our imagination for years to come. Let me explain the specific spectral lines we are seeing in the last hour. The sodium, Na, doublet has appeared. Sodium tails are beautiful. We saw one with comet Neowise. Sodium is heavy, it doesn't hang around easily. Seeing it now means the sublimation depth is increasing. We are stripping off the outer layers and digging into the mantle of this object. The sodium is glowing bright orange in the spectra, though to the eye, the comet remains blue-white due to the dust scattering. This mixture of chemical signals, blue continuum from dust, orange lines from sodium, ultraviolet pumping from CO, creates a complex soup that is a nightmare to model. What really concerns me is the distance to Earth. It's closing in. The close approach on December 19th is 1.8 AU. That is safe. It is not a near-Earth flyby in the dangerous sense. It's 270 million kilometers away. But it is close enough that if this brightening continues, it might become visible to high-end amateur telescopes, maybe even binoculars, if it outbursts significantly. When the public can see it, the narrative changes. It stops being a debate in the journals and becomes a global phenomenon. I am looking at the trajectory residuals again. There is a tiny wobble, a deviation of maybe 100 kilometers from the predicted path over a billion-kilometer arc. It's barely statistically significant, 3 sigma maybe, but it correlates with the pulses. Every time the brightness spikes, the object nudges slightly. It is a propulsive event. We are watching an engine, a natural engine, a thermodynamic engine, at work. The efficiency of this engine is what puzzles me. To get this much thrust from this much light, the exhaust velocity must be incredibly high, supersonic relative to the nucleus sound speed. This requires a nozzle. You don't get supersonic flow from a flat surface sublimating. You get it from a constricted vent, a de Laval nozzle structure formed by ice and rock. The odds of a random rock having a perfectly shaped nozzle pointing at the sun are low. But with billions of comets, the law of large numbers says it will happen eventually. The mood in the Slack channel for the observational team is tense. We have colleagues in South Africa and Australia waking up now, taking over the watch as the object dips into the southern sky visibility. The text messages are short. Did you see the flux? Confirmed. Check the flat fields. Flat fields are clean. No one wants to be the one to cry wolf, to claim a major anomaly that turns out to be a satellite passing in front of the lens, but the consensus is building. 3i Atlas is undergoing a phase transition. My working hypothesis, and this is what I will draft in the morning, is that the object is cracking. The thermal stress of the last few months has finally penetrated the core. We are seeing the formation of a fissure. As the crack opens, it exposes fresh, volatile ices that haven't seen the light of a star for a billion years. These ices are sublimating instantly, explosively. This creates the jet. The jet spins the object. The spin creates centrifugal force, which opens the crack further. It's a runaway feedback loop. If this is true, we might be about to witness the disruption of the object. It could shatter into a swarm of fragments in the next few days. If it shatters, we lose the chance to study the singular body, but we gain the chance to study its insides. A debris cloud would give us a cross-section of an extrasolar world. We could see the stratigraphy, the layers of its formation. Was it a planetesimal? A fragment of a larger moon? The debris will tell us. But what if it doesn't break? What if it keeps brightening and accelerating? Then we are in uncharted territory. An object that survives the sun, accelerates on the way out, and actively dumps energy. That is a behavior that mimics life, or at least mimics directed purpose. I try to keep that thought locked away. It's unscientific. But when I look at the screen, at that sharp, rhythmic spike of light, it feels like looking at an EKG. It feels like watching a heartbeat. The data download from the Swift Observatory just completed. I need to process the X-ray data. Comets emit X-rays because the solar wind slams into the gas cloud and exchanges charge. It's called charge exchange emission. The X-ray flux usually tracks with the gas production. If the X-rays are spiking, it confirms the gas theory. If the X-rays are flat but the optical light is up, it means the brightening is from solid dust, not gas. This distinction is crucial. Processing. The X-rays are flat. Okay, that stops me in my tracks. The X-rays are flat. That means there is not a massive increase in the gas cloud interaction with the solar wind, but the optical brightness is up. This means the brightening is almost entirely due to dust or solid surface changes. It's not a cloud of gas, it's a cloud of mirrors. Or the surface itself has changed reflectivity. Did the dark crust flake off, revealing a pristine white ice surface underneath? That would explain the albedo jump without the gas. A facelift for the comet. It shed its old dark skin. This fits the shedding theory. The negative polarization suggested a dark surface. If that surface is gone, the polarization should flip to neutral or positive. I need to call the team in La Palma. We need a new polarization measurement immediately. If the polarization has flipped, we have our answer. 3i Atlas just molted. But why the pulse? If it molted, the whole surface should be bright. The pulse implies the bright patch is localized. So it didn't shed the whole skin, just a patch. A window opened. A bright, icy window on a dark, rotating world. I am going to keep recording these logs because things are moving too fast for formal papers. The history of 3i Atlas is being written in real time. We are the first generation of humans to have the technology to not just see these visitors, but to dissect them with light. We missed Oumuamua. It was too fast and we were too slow. We caught Borisov, but it was just a normal comet. 3i Atlas is the one we've been waiting for. The oddball, the anomaly, the brightness just ticked up another 0.1 magnitude. It's not stopping, it's getting brighter as I speak. The contrast against the background stars is becoming stark. In the raw images, it's no longer a smudge. It's a hard point of light with a halo. The halo is the coma. It's expanding. I have to wonder where this object came from. The galactic trajectory points back to the Carina Sagittarius arm, but the error bars are too big to pinpoint a specific star. It has likely swung past thousands of stars before it found ours. How many times has it done this? Flared up, brightened, and then gone dark again in the cold between suns? Is this a cycle? The screen is flashing a proximity alert, not for Earth, but for a data packet arrival. The Hubble Space Telescope imagery is downlinked. I'm opening the FITS files now. Okay, this is unexpected. The Hubble image shows the nucleus. It's not a single point. It's elongated, bifurcated. It looks like a contact binary. Two objects stuck together, like a snowman. We've seen this before. Arakoth, Comet 67P. It's a common shape. But the neck connecting the two lobes is glowing. The brightness isn't coming from the surface generally, it is coming specifically from the junction between the two lobes. The stress of rotation is shearing the neck. The structural failure is happening at the weakest point. This explains everything. The heartbeat is the rotation of this dumbbell shape. The brightening is the fresh ice in the neck being exposed as the two halves grind against each other. The non-gravitational acceleration is the jetting from this fracture zone. 3i Atlas is breaking in half. We are watching a slow-motion divorce of two interstellar stones. If the neck snaps, we will have two objects, 3IA and 3IB. They will drift apart. The brightening we see now is the final scream of the structure before failure. This is a verified observation. I am looking at the pixels. The bridge of matter is distinct. I need to calculate the torque. If the spin rate increases, the centrifugal force will snap it. I need to measure the rotation period change in the next few hours. If it drops from 16 hours to 15, then 14. It's spinning up. It's winding up for the break. This is the reality of science. It's not always aliens. Sometimes it's just the violent, beautiful physics of gravity and cohesion losing a battle against momentum. But watching an object that was born around a star that died billions of years ago finally meet its end here, in our little corner of the galaxy, is profound. We are the witnesses to its final act. I'm going to upload the coordinates for the debris field tracking. If it breaks, the pieces will fan out. We need to warn the Mars orbiters. The dust trail could intersect Mars orbit in a few months. It's a low risk, but a non-zero one. Wait, I'm zooming in on the southern lobe of the binary structure in the Hubble image. There's a second point of light, distinct from the neck. It's not on the surface. It's orbiting? No, that can't be right. A moon? An interstellar comet with a moon. If it has a moon, the mass calculations are all wrong. The dynamics are all wrong. A moon stabilizes the rotation. If there is a satellite, it explains the stability of the axis. This is getting more complicated by the minute. I need to run the photometry on that second point. Is it a background star? I'm checking the catalog. No star at those coordinates. It's moving with the comet. 3i Atlas is a binary system, a primary and a secondary, and they are reacting to each other. This changes the entire dynamical model. The brightening might not be a fracture, it might be an eclipse ending, or tidal heating between the two bodies.